Hey everyone, so here we'll be solving another problem in this ongoing stack playlist, which is maximum width ramp. So what this problem says, you are given an integer array nums and you have to find width of ramp. Now see guys, if you read this problem, what a ramp means. So a ramp is basically a pair of two indices I and j. Okay, and what are the properties of these indices? First of all, j should be greater than or I should be less than j. This is first. And the other property is nums of I should be less than equals to nums of j. Okay, nums of I should be less than equals to nums of j. So here I have written like this test case I have written over here, if you can see. So at this point there are few possible I and j pairs, so there are few possible ramps that I have like written down here, so which are 0 2 1 3 1 4 3 5 1 5. So these are indices, and following this property that j should be greater than I, and the value at j should be greater than equals to value at I. Okay, so then I try to calculate j minus I, and here you can see this 2 2 3 2 4. So in this way, what you have to do, you have to calculate the maximum, you have to calculate maximum such width, okay, that you can get. And there can be many more possible pairs, but this one 5 minus 1, okay, this 4, it is the maximum. Here you can see the answer, this is the maximum. Okay, now so in brute force, obviously in brute force what you can do, for every I value, so here if you see this this array or vector, whatever it is, for every I value, for every index, okay, you can go where, let's consider for this index, you can go in its right. For every other index, for every index, let's call it by variable I, because you will iterate like to every index. For every index you will iterate, and you will check with which other indexes it can make a valid ramp. Okay, then you will calculate this. So for every I, you will go to every other j, and like every other index by and by like while going to every other index, you will obviously will use a inner loop, and there you will be using j variable, obviously some other variable, not just I. So in this way you will require two loops. Here if you see the brute force of it, starting from I assign 0, you'll go till last, then there will be a j value, like for every I, the inner loop where you'll be going from I plus 1 till last index. And just you'll see this, you'll make sure that you follow this condition properly, that if you're if you satisfy this condition, you'll update your a, let's say that you are having a ans variable, you will update that with the maximum of whatever you are getting as j minus I. Then at final you will return what? You will return ans. Okay, you'll return ans. Obviously if you see this loop, like inner loop and outer loop concept, so roughly you will say that this is order of n square. Okay, roughly you will say that this is of order of, this is of order n square time complexity. Okay, so obviously we can optimize this solution, but I'll not go, because see there are ways to optimize solutions. Either you can directly optimize your brute force, or you can see observations and test cases. Okay, uh, so as I like when I was trying to solve this problem, optimizing from brute force, I was not able to do that. So let's see and think in test cases what all observations you are getting, and we will try to like put down all the observations at some point, at some place, and then we'll see what is the optimal data structure or algorithm for this to really solve this problem. Okay, so now guys, be with me, and you will eventually see how this problem, like how to optimize like solutions and everything using test cases. Now let's get our observations right. Okay, so what I say is, consider this fact. This is your nums array right now. Okay, this is your nums array, or we can call it vector, whatever. So let's see for this 4. Let's say let's see for this 4, which is 0 index. So till what point, like if you say this is your I variable, this is your I, so who can be its j? Obviously, because we have to make sure that you keep this condition right. Okay, nums of I, it should be less than equals to what? Nums of j. So who can be its j, or who, like with for this I, who all can be its j? So obviously in its right, whosoever is greater than or equal to 4. So it can be 5, it can be 8, it can be 10, and this 10. Okay, but if you see this, this 4 will get compared with this 5, 8, 10, 10, because they are following this constraint and they are in right of this I. But Can you say, can you directly tell me which j value amongst this 5, 8, 10, or 10, which j value, if with which j value this I will make the maximum width? Will it be with this 5 or 8 or this 10 or the final 10, which means the largest value with which with this 4 will make the largest, the maximum width ramp? Obviously with the largest greater value. Okay, with the largest greater value. Now let me remove this. So you can get this hint, the first hint, then the first look, this is the way that you anyone, like if you're beginner or even if you're intermediate, so you'll get your observations in this way, and it's better that you write it down. So what you will do, get the largest element in right, get the largest element in right. Okay, because what I'm saying is, even if you consider this one, so obviously first of all, if you see this 5, so in this way 5 can make with this 8, 5 can make with this 10, then 5 can make with this 10. So first of all, this is for sure that in test cases like these, so 4 will be making, so like, because what I'm doing, like what we are trying to see is what, because earlier in brute force what we were doing in brute force, for every I we were going to every other j. Okay, and that is what, like we are doing comparisons, and then we are having order of n square comparisons. But what I'm saying is, here we are trying to see like which all comparisons we can avoid. Okay, so this 4, look, we are not bothering right now that what is your optimal answer, like what is the maximum width right now, because there are other elements to be compared, the 3 and 2 are remaining. But what I'm saying is, which are guaranteed comparisons that you can avoid. So if there is a bigger element like this, so because this is at rightmost, it is the rightmost bigger element. So what you can say, whatever width these they will contribute, you'll surely get a bigger width, this bigger width this with this 10, because it is in right. Okay, that is what I wrote here, that get the largest element in its right, because then certain you are certain that you are sure that to left of this, to left of 10, whoever is making width with this 5, 3, 8, 10, because when they'll make width, when their value is lesser than this 5, 3, 8, 10, whatever, because you have to follow this constraint. And as this 10 is largest going in right, so if they are making width with 5, 3, 8, 10, they will also make with this 10 as well. And this 10 is at the rightmost of the all of them, at the right of all of them, so the width will be even larger. Okay, so first thing, you got that get the largest element in right, and so that you can avoid all these unnecessary comparisons. Now let's because obviously to get all the observations, what you have to do, and what I do personally, I make sure that I try to like solve multiple test cases and on different scenarios. Okay, because I need to like look, before this 10, like before this 10 you are sure, like out to all these elements you are sure that they will not contribute to your maximum width. This 10 may contribute. Okay, but again you are remaining with 3, 2, again where you are, because you don't know what like can you avoid this 3, 2, or what their status is, like how can they contribute to your answer, because before this you are sure that no one can contribute to maximum width than this 10. Okay, because 10 will be maximum. So now let us see what we can think of this 3 and 2. Let's modify a few things in this test case itself, and then we will see this. Okay, so say if I remove this 4, look, this is how you have to go with test cases. Okay, when you are sure about something but not for others, try to incorporate changes in your test cases that make sure that make use of those values. So because these 3 and 2, let's see what we can think for them, sorry. So if you put, like if you have 4 here, and if you put 3 in place of 4, so what you can say, look, obviously in up to this region, who will contribute to the maximum width, which element will contribute the maximum width for this 3? Obviously 10. So this check is true, that all these elements are not required, in fact this 10 can, if you check this with this 10, it will contribute to a maximum width than these elements. Okay, so this observation is not going anywhere. But what I say, this 3 will make even bigger width than this 10 with compared to this 3. Okay, so this 3 will make even bigger width, so the index number 0 will make a bigger width within index number 7, not with 10. Okay, so this observation is not going anywhere. See guys, you're getting in observations, okay, because you have to write a code, a general code for all test cases. You cannot write code for every test case separately. So just we are seeing what all possibilities we are having. So this observation is not going anywhere, that when you get the largest element, at least you are avoiding unnecessary comparisons to its left. Okay, now see this 3. So you know this element, this 3 will make a bigger width with this 3. Okay, that's all right, but again for 2 you cannot say anything. For 2 you cannot say anything. But if, let's say, if I remove this 3 and I say I'll put 1 here, or 1 or 2, whatever. Okay, so this one, obviously, again, if you see this comparison this observation is not going anywhere. This one will make, let's say, if you see in this region, you don't have to even bother about the maximum width, because compared to this 10 will make a bigger width. Then, but you know that this one will make the maximum width with whom? With this 2. With this 2. Okay, because index number 0, index number 8, 8 minus 0, 8 is the maximum that you can get corresponding to this 1. So, and if you see for all the values like this, okay, so you got what? If you see this idea, guys, just pay your attention with these test cases and get your observations right. Okay, this is how I make sure that if I'm stuck at some problem and I'm not able to optimize the brute force, use test cases. Test cases are your power then. Okay, so you saw this, right? That get the largest element in right, that is all right. The second point is, then if you see this, what is the nature of this array, or sorry, what is the nature of this part of, or this remaining elements? So obviously it is descending sorted. If you see this, what I mean by this, see guys, if you're having a, like right now you're having 3 and 2, but in other, in let's say in some case, they let me just write here, because see, this nums of I and they are not required anymore because we know the properties. So let's say if I am having some index 9, which is element 5. Okay, having element 5. Now see guys, if there was any element 1, if there was any element 1 right here, it was making a width with this 3 2, or with this 2 earlier it was making maximum width. But you know, this 5 is even greater than equal to this 2. This 5 is larger than this 2. So now this 1 will make even bigger width than this 5. So what you can see, because now this 1 will make even bigger width with this 5, not with this 2. Okay, so what you can say, you will get a maximum, let's say you get a largest height, no problem. Then what you have to make sure that you try to keep things in descending order. 10 3 2, if the 5 was not here, then 3 and 2, they were also important. But as soon as 5 came, which was greater than 2 and 3, the importance of these 3 and this 3 and 2, it vanished, because whosoever is creating width with this 3 and 2, they'll also make sure they'll make width with this 5. Okay, you are pretty sure about it now. So what I'm saying is generally, and if you see this thing, that if you see this test case and if you get all your observations right, so first thing is, you'll get the largest element in right. Then what you have to do, first you have to get the largest element right. Then what you have to do, make your that structure or whatever, like, because you will keep somewhere, like you will keep this 10 on some data structure, or on some container. Make your structure descending sorted, or like keep your structure descending sorted. Okay, descending sorted. What I mean by this, look, before this 5, when 5 was not there, so this 10, because look, why this 10 is important, because this 10, if you only compare with this 10, or let's say not this is well, not with this 10 but with index, because we have bothered about this index j minus I we need. Okay, if you see the index number is 6. Okay, so if you see this 6 index, so before these indexes they were unnecessary, because this 10 was greater. This 10 was greater. Okay, this 10 was greater than all of them, or you can say greater than equal to. So whosoever were making comparisons with width with this 5 3 8 10, they'll also make with this 10 and even a bigger width. Then you saw that this 10, okay, this 10, you can say something about this. So these are not required, so that is for sure that these are not required, that they're guaranteed. But earlier you were not sure about 3 and 2, but when you got this 5, now you know that one more thing, you know that whosoever is making width with this 3 and 2, because 5 is greater than this 3 and 2, then they will make a even bigger with this 5. So you got this information that now this 3 and 2 are also not they are also unnecessary. Why? Because 5 will do their job. Okay, because 5 is greater than these two elements, 5 is greater than these elements, and it will make even bigger width. So if you see just this example, so what only width, what only j values, because look here, whatever you're doing, for every I you are going to every other j, but here if you see guys, for every I, which j's are required, because we removed every unnecessary j, the only j that are required is index number 6, which is of value 10, and index number 9, which is of value 5. Okay, I hope you are getting this guys, because here we reduce number of j's, and by reducing number of j, you know, you are reducing number of comparisons. Okay, so the question is, because see, now what you got your, from this array you got all required j's that are like, that are required, like all the j's that are really required. You removed all the unnecessary j values that are like not contributing to your answer, but in your brute force you are having comparisons for them. Okay, now what I say is, see this guys, now what I say, let me just finish this. So if you see this, what was the index number 9 6 and index number 9, these two are of these two are of only importance for us. Okay, the value is 10 and 5, that is all right. So here if you see, what you are having 4, you are having 4 right here. Okay, you are having 4 earlier, initially the element 4, and you know that only and only j, index number 6 and 9, they are required, like which are value number 10 and 5. So see, because so if you see this carefully guys, because this was your first part of, like, this was your first part, like you can say half of the problem you have solved, because you have tried to form j. Okay, you have tried to get all the j required, all the necessary j that are required. But we can, you again look, let's think more, and let's think in a way that can we again remove, like do something, because look, for every I you again have to compare with these j's. Okay, for every I you have to compare with these j, but what is the property of this value? They are descending sorted. 10 5. What if your given array was like this, 10 9 8 7 6 5 4? So if you see this, so if your given array was like this, it had the property of descending sorted. So you know that all the j's were then required, all the j's were required, because you were keeping this as descending sorted. Okay, so keep like getting making descending sorted from this array is only half done, because it is because you don't, because if your array is already descending sorted, then it will not help you in any way. Okay, so now let's see, can you further like optimize this, because with this j, let's see. So if you see this 4, if you see this 4, if you, because these two were j's only, 6 and 9, so as I'm like marked them with this red colors, so these two are only required. Now what I say, let's see, forget about this 5 as of now, just pay attention to this 10. Okay, look, we tried to remove all unnecessary observation, all unnecessary comparison that are required. Okay, so with this 4, if you put a line here, okay, on this 8 10, so this 4, if you see, this is the width, right? This is the width. While going from left to right, you encounter first element who can make a pair with this 10. So this is the width. Now see guys, once this width with this 10 is done, now you know you calculate this width, and you keep a variable ans. Now you move to right, let's say to this point you got some other element, and you calculated this width. You again move to right, you calculated this width. What are you seeing? That once you encounter any element who can make up with this 10, the job of this 10 is done, because now if you go to right, any other element who is like valid, who like I and j pair are valid, but you know that their width will be smaller because you are moving towards right. So what you mean, once let's say you get with the 6, once whatever width you were going from left to right, you get with this 6, this 6 is not required anymore. Okay, you also obviously you are having this variable ans, you'll update ans variable with this 6 minus 0, 6 minus 0. So then after which is value 6, then you will remove this 6, you will remove this, because this 6 is not required. Okay, afterwards going in right, this 6 is not required, because see, if you compare this 2 with this 6, obviously they'll make a pair, but 6 minus 2, you know, you moved right. 6 minus 2, so 4. 4 is not greater than 6. So now you'll not get anyone who can make a valid pair with 10, this index 6, and maybe a bigger width than this. No, there will be no element. So this 6 is done. Now see, because you know there were two potential j's. There were this much potential j that you can compare. Index number 6, index number 9. So this 9 is remaining. This 9 is remaining. So 4 with this 6, you got 6 width. Now let's consider this 4 value, which is in the index number 0, remaining with this 9, which is this 9 if you see right here. So 4, index number 0, index number 9. Obviously 4 is less than 5. So 0 minus 9 minus 0, which is 9, and 9 is even greater than this 6. So I'll update this 9. So you'll update the 6 to 9. Now what you can say again, see guys, because if you let me remove this, like is or create a space. So if you see this carefully, if you put a line here, this 4 got a maximum width with this up to this line. Like if you say this is the maximum width. Now if you go in right direction, so this will be width. Let's say if there is some I which is valid, again if you go in right, this will be valid width. So what you can see, once again when you get the maximum width, or sorry, once you get a valid pair while going from left to right, the importance of this line is also finished, because now if you go to right, you will get a smaller width, not bigger width. Okay, so you again remove this 9 as well. So finally you can say, because see, now all the j's are finished. Now all the j, whatever you required, whatever like they were like potential j or the favorable comparisons, because all were unnecessary before this. So comparing this 4 with these elements, they are not required, because this 10 is overshadowing their importance. Okay, and then later you saw that when this 10 was done, so whatever j was now like whatever j has the potential to increase your width, which was 5 only, and you compared with 5 as well, and you saw that once you compared with 4 with 5, once you compare this 0 index with 9 index, because if you move in right, you will reduce the width. So you are done. So once you finished with this j, you are done. Okay, so there are like if I try to like if I try to summarize this problem, so the first step was to get all the required j's, to get what we can say, see, not required, we can say that to remove unnecessary j's, because it will remove unnecessary comparisons, to remove unnecessary j's. Okay, to remove unnecessary j's, okay, j values. And second was to like solve the problem, like iterate, like go from left to right and solve corresponding with this j. Okay, now see guys, how can you, because see, our only problem now comes with this thing, that how will you get the 6 and 9? See, you know you have to get the 6 and 9, but how will you get? Because if you consider this fact, now let's see this. You need 6 and 9 somewhere. Okay, you need 6 and 9, and here you saw that what was the property of this structure, because you have to keep the somewhere. There can be multiple values, 3 4 5. Right now it's only 2 value, but there can be multiple values. Okay, but you can what you can say about this, the property of this structure where 6 and 9 are sitting. So you can see that the element, because these are your potential j's, so you were going from left to right, so these were all your I values. So they were what, they were getting compared with this 6. You were removing then this 6, means you're popping out this 6, because this 6 was done, so you popped out this 6. Then you went to 9. Okay, then you went to 9, you saw that 9 is also a valid one, and you made a width, you again popped this 9. So which means you need what, you need a pop. Okay, you need a pop. You have to use some data structure where you are getting this functionality of removing something, okay. And now this was one thing, one hint. Okay, to remove which data structure you can use, either you can use queue or you can use a stack. You are having these two data structures. Okay, let's go ahead, because now you have two options. What I say is, with amongst both of these, which you can use. Okay, so if you see a simple fact here guys, so see, this solution may be a bit lengthier, but I'll try to explain everything यार. Just be with me, because I don't want कि तुम लोग यहाँ से कुछ आधा अधूरा ज्ञान लेके जाओ. ठीक है, कि आधा समझा दिया, आधा नहीं समझाया, नहीं, पूरा समझाएंगे कि अब तुम्हें why you like in queue and stack, which one you should aim for. Okay, so now see, when you're making this structure, whatever it is, queue or stack, now you are sure that amongst these two we'll need, because we want pop operations, and who can give me pop, queue and stack. So see, first thing is, you wanted to make this descending sorted. This data structure you wanted to make it descending sorted. Okay, and you saw here that, let's take this example. You got 10, no problem. Then you got 3, then you got 2, then your new element was 5. So if you have to make this like descending sorted, so you have to remove 2, you have to remove 3, you have to put 5 here. Okay, you have to put 5 here. Now see this. In this example, let me just expand this and say I am having 15 these elements. Okay, their values 15, 11, 15, 12, 11, 10, 3, 2. Okay, till this point, see guys, till this point this array was sorted, descending sorted, so they all were important to us. These all j's were somehow important, because see, before them you're confident that this 15 will handle all the values, because this 15 was, let's say, largest value. Okay, now see, when your 5 was coming, see guys, see this properly. When your 5 was coming, so what is, see, you have to remove the smaller elements. Okay, but where you have to remove the smaller elements, if you see, which are the smaller elements first, 3 and 2. So if you go from this first positions, if you go from these first positions, 15 is greater, 12, 11, 10, 3, 2. So how many comparisons you will do? 1, 2, 3, 4, 5, 6 comparisons. If you go from first, okay, now let's go from last. 2 is lesser, you will remove 2. 3 is lesser, you will remove 3. 10 is greater. So afterwards, after 10, everyone is either greater or uh, greater than or equal to, okay, with this 10. So you should not go to right, because you will not get lesser than 10. All elements are in descending order. So now you got that, going from last and removing these things and creating this structure, you will only do 3 comparisons. So you got this idea that I'll go from last, or I want what, last values, which means LIFO thing. I want some data structure which gives me pop operation, and a data structure which follows LIFO property that will be feasible for me. And who is that? Obviously stack is that. So from here you should be getting your intuition right, that stack is the data structure that I will be aiming for. Okay, but see guys, normally in all the problems, what we did, we went from left to right to fill our stack, to prepare our stack. We went from left to right, but here there is some trick. Okay, you cannot go from left to right and filling a stack. See, you got this idea that you want a stack. This is clear for you here. Now, but the issue is, see, when you go from left to right, you will get, because you will encounter 10 first. So in stack, what you'll do, you'll put 10 here, then 3 and 2 they'll be removed, and then you'll encounter 5. So actually, if you see in stack, you are getting 5 then 10, because stack, what it follows, LIFO thing, last in first out. So you'll get 5 if you try to use this stack. See, you fill the stack normally from left to right, and when you try to use the stack, you'll get 5 then 10, which means you'll get first index number 9, then the index number 6. But here we saw what we want, index number 6 first, then index number 9. Okay, index number 6 first we want, because obviously in brute force you saw how we solve the problem, by left to right. Okay, this structure was only required to remove the unnecessary j values, but primarily how you're solving the problem, by going left to right. Okay, so we want this order, although we need a stack, but we want somehow this order. Obviously you cannot go from left to right, you have to go from right to left, because then 10 will be encountered at last, which means 6 index will be encountered at last, so it will be popped first, so you can get these 6 value at first. Okay, so here you got this idea that you will use a stack, and to fill that stack you will go from right to left. Okay, now let's see what my solution is. I won't drag this topic further. So obviously I created a stack, so I am going from right to left, and what I'm doing, if obviously if my stack is empty, I'm pushing it, the element. Else what I'm seeing is, see, what we wanted when you were having 3, 10, 3, 2, 5, and all the elements were lesser than equals to 10. So now you are going from right to left. So what you will do, because you have to put in stack, you have to put how you have to like fill this stack in descending sorted. So if you are, let's say, having 10, because obviously you want 10 and 5, these two elements are required, because for these 3 and 2, 5 will do the job, because obviously whosoever is making width with these 3 and 2, they will make width with this 5 as well, because 5 is also greater than will be greater than those elements. So this 5, you will put 5, then you will put 10. Now how to achieve this sort of thing? Because going from right to left, your top is 5, let's say, first, because it stack was empty, so you push top, you pushed 5. Now see, these 3 and 2 now are not required. Why? Because they are lesser than 5. So you'll only enter something in this stack when your top value is less than them. But for this 3 and 2, they are not less than, for 3 and 2, they are lesser than. Now you'll only enter something in this stack when the value is, when this value is greater than 5. So you'll make sure that you'll only enter when your nums value is greater than your top value. So in this way you'll prepare your stack. Okay, so finally, as you know, after preparing this stack, what we did, we tried, then we went from left to right for every I. Now see, the j values, all the necessary j values, all the unnecessary j values, they are removed. Only the required one who can really contribute to your answer. Okay, like with whom you are confident that I only require these j's, other j's I am confident that they will not contribute to my answer, that is for sure. So for these j's, you will do that, you will do this thing, that you will go from I assign 0 like till last index, and you know what you have to do, the simple drill, that as you saw here earlier in this example, that you encountered some index, you will compare with this top value, and you will see that is this making a valid pair or not. See guys, that is why we kept the descending order. Okay, because if this 4 was able to make with this 10, which means this 4, see, if 4 was able to make with this 10, so you are sure that this 10 is not required, you will remove this. Then you will go with what, with this 4 you will compare with this 5. Okay, you will go with because then you are sure that this 10 is not required. Okay, and this is what you did here. So you'll do what, for every I, let's say you're going from right left to right, you will get you'll get your leftmost value, which is making a valid pair with your top value, stack's top value. And as soon as you get that, calculate a maximum ANS, like update this ANS variable, and remove that 10 from this stack, remove that 10 from this stack. So you'll do the same drill for everything, like for the entire stack. And like once you are done with I, and once you're done with everything, you'll return your ANS variable. Okay, your ANS variable. Now guys, see, I know this question was a bit lengthier, like on a bit lengthier side, obviously 30-35 minute video, but I made sure that there will be few problems like this where you won't be directly optimizing from your brute force. Okay, because directly getting hints from brute force is not always like the case, but what is the best case is you are having test cases. Okay, so try to get your observations from test case. And even right now guys, if you're not getting the idea, go and see this video on repeat, and just see, don't focus on this solution यार, ये सब तुमसे हो जाएगा, बनना है धीमे धीमे। तुम फोकस करो सिर्फ किस पे, टेस्ट केसेस पे, वहाँ से ऑब्जर्वेशन पुल आउट करो और देखो कि उन ऑब्जर्वेशन से तुम कौन सा डेटा स्ट्रक्चर एल्गोरिथम निकाल सकते हो। देखो, आई नेवर सेड गो फॉर स्टैक अगेन हियर till I think 25 minutes. I never said to go for stack. I only emphasized on test cases. Once with the test cases you are done with that, and you know that I need this functionality, then see which data structure is more aligned with these functionalities. Okay, I hope guys you will like this video. Do let me know in comments, like are you getting this? Because see, एक मेन फंडा समझो यार, अगर मैं तुम्हें सोल्यूशन ऐसे हूबहू दे दूंगा ना, सो आई एम नॉट हेल्पिंग यू गाइज इन एनी वे, फिर वो ऐसा हो गया रटवाना जैसा हो गया इंटरव्यूज में या फिर यहाँ वहाँ कहीं भी तुम, क्योंकि तुम रट के जा रहे हो, तुम मेरे इंट्यूशन समझ रहे हो, तो इसीलिए अपन डायरेक्टली इंट्यूशन नहीं देंगे किसी को। ठीक है, क्वेश्चन सॉल्व करेंगे, समझेंगे चीज़ों को, और टाइम लो। ये बिगिनर्स जो है, टाइम लो आराम से, तुम बिल्ड करो लॉजिक अपना, सोचो कि ये भैया कैसे सॉल्व कर रहे हैं, हम कैसे कर सकते हैं सॉल्व। ज़्यादा उस पर सोचो मत इतना कि यार ये बहुत टफ क्वेश्चन है ना, ऐसा है वैसा। चलो मिलते हैं बाद में, बाय।